The size of A is 13, correct? So at the moment, the direction is determined by vector A. But what is still undecided is the situation with vector B, isn't it? The direction is not determined, only the size is determined. So we don't know which direction vector B is pointing, but we saw the size is 15, and we don't know the direction. They just told us the size. A told us both the size and the direction. So vector A has both magnitude and direction determined, but vector B only knows the magnitude and doesn't know the direction, right? So what are they asking us to find, guys? They're asking you to find the range of the magnitude of the vector obtained by adding two vectors. If vector B is formed like this, then the vector A plus B vector would look like this, right? The addition of these two vectors. When a new vector emerges, we must find the range of its size. To determine the range, we consider the maximum and minimum values. By adding these two vectors, the size will be greatest when they align in the same direction. Therefore, we are asked to find the range of the size of the vector when it occurs. When adding two vectors and their directions are slightly different, we draw a parallelogram like this. You know what I mean, right? As the angle narrows, the size value increases. To make the size the largest, the directions of the two vectors must match. To make the size the smallest, the directions of the two vectors must be opposite. Currently, vector A has a fixed size and direction, while vector B with a size of 13 only has a fixed size. When the two vectors are added, the size becomes the largest when they have the same direction. When that happens, the size becomes 28. The max value is 28. On the contrary, when it's the smallest, it's 13 on this side and 15 on the opposite side. If vector B points to the opposite side of vector A, when they're added, the size becomes 2. So the max value of the size of the added vectors is 28, and the min value is 2. Now what does B say? When the sum of those two vectors is at its minimum size. When is the size of the vector that is the sum of the two vectors at its minimum? Can you find P when a vector is facing this way and has a magnitude of 13, and B is also facing this way? What's up with P, the sum of these vectors? What occurs when you add them? Hey, this is a 2-unit vector in this direction, right? How the heck am I supposed to find this vector? Do I need to know two things? First, is it size 2? Second, is A going in the opposite direction? Well, when you're looking for this, it's better to start by creating a unit vector, always knowing the exact direction. The direction of vector A is 12, right? So the opposite direction of this would be, well, if we put a minus sign in front, it would be minus 12, right? Then we need to create a unit vector, always a unit vector. By taking the vector in the opposite direction of A and dividing it by the magnitude of 13, you can create a unit vector with the opposite direction of A vector and a magnitude of 1. Do you comprehend and grasp the concept of this calculation and its implications? What we are looking for is a vector of size 2, so we multiply 2 at this point. It is great to create a unit vector of any size, so we can simply multiply it. Do you comprehend this? So what's up with B asking us to meet and find something? So you want to create a vector with a size of 2 that's opposite in direction, right? Where do you want to start? You say you create a unit vector with opposite size, then multiply it by 2. How do you make a unit vector with opposite direction? First, you multiply by minus to reverse the direction, and then divide by the magnitude of this vector to create a unit vector. Then you multiply it by 2 to create the p vector.